In this video, we will be talking about the terms current, voltage, and electrodes. Redox reactions that are used in electrochemical cells are essentially reactions in which electrons are passed between the reducing agent and the oxidizing agent. So when we're trying to get energy out of them, we typically will take those two cells, separate them, and pass the electrons through a wire. The term for the rate at which electrons flow through the wire is called the current. Now, electrons flow through a conductor in response to an electrical potential difference, similar in thought to water flowing downhill in response to the difference in a gravitational potential energy. Electric current is the amount of electric charge that passes a point in a given period of time, whether as electrons flowing through a wire or ions flowing through solution. We can sort of think of electrical current as akin to volume, the volume of a liquid that passes through a hose. Again, redox reactions are those that involve the transfer of electrons from one substance to another. Therefore, in these redox reactions, we have the potential to generate an electric current. That is done by separating the two components of the reaction. So to use the current, we need to separate the place where the oxidation is occurring from the place where the reduction is occurring. By separating the two components, we can then force the electrons to transfer between them via a wire, and because current is a measure of the amount of charge that is flowing through a wire or through a substance, by separating the two components and forcing the electrons to transfer between, that's how we end up getting a current. So current is the number of electrons that flow through the system per second. The unit that we will be using for current is the ampere, sometimes called the amp. 1 amp or ampere of current is equal to 1 coulomb of charge flowing through our system each second. And to get 1 coulomb of charge, that 1 amp is equivalent to 6.242 times 10 to the 18th electrons moving per second through our system. Now, because we're talking about electrical cells, similar to, well, a battery is an example of an electrical cell, the electrode, where the oxidation and reductions are going to take place, the surface area of those electrodes will dictate the number of electrons that can flow. The bigger the electrode, the more electrons are able to be transferred at its surface per unit time. So larger batteries are going to produce larger currents, and that's because the larger batteries will have larger surface areas on their electrodes. Now, if the current is analogous to the volume of water flowing through a pipe, then the voltage would be the pressure that is pushing the water through the pipe. So the voltage in terms of an electrochemical cell is the difference in potential energy between the reactants and the products, and is often called the potential difference. The unit for voltage is the volt. 1 volt is equal to 1 joule of energy per coulomb of charge, and it is the voltage that is required to drive the electrons through the external circuitry. If you didn't have that potential difference, then the electrons would not flow from your anode to your cathode in a voltaic cell. The amount of force pushing the electrons through the wire is called the electromotive force, or EMF. Now, the component of an electrochemical cell that is responsible for the transfer of the electrons between your oxidation component of your reaction and your reduction component of your reaction are called the anode and the cathode. There are a bunch of different acronyms for remembering which electrode does which particular component. A popular one is an ox and a red cat, which stands for anode is the oxidation, reduction is the cathode. I personally prefer to remember that anode starts with a vowel, so does oxidation, reduction starts with a consonant, and so does cathode. But whatever method works best for you, rely on that. The anode is the electrode where oxidation occurs. The anions, the negatively charged ions, are attracted to it, and that's where the anions in what we will see later, called the salt bridge, the anions in the salt bridge flow towards the anode. It is connected to the positive end of a battery in an electrolytic cell, and it's the one that will lose weight in an electrolytic cell. The cathode, on the other hand, is the electrode where reduction occurs. Cations are attracted to it. So in the salt bridge is a salt, so it has a mixture of both anions and cations. The anions in the salt bridge solution flow towards the anode. The cations from that same salt solution flow towards the cathode. The cathode is connected to the negative end of the battery in an electrolytic cell, and typically this is the one that will be gaining weight in an electrolytic cell. The cathode is the electrode where the plating takes place in electroplating.